And we are live. Let me know whether you can hear my sound very clearly and whether so this is my chat. Welcome. Thank you so much for joining. This is our live session here on YouTube. Most of you come from other. So thank you so much for joining. Let me know if everything is okay. So thank you so much for joining. Let me know if everything is okay. So thank you so much for joining. Let me know if everything is okay. So on this box, this is the live. This is a cutout, specifically a double cutout, where you have this part which is housing the, then we have this part which is having the neutral connection. We also have an energy meter. An energy meter is basically where your electricity is billed, where power will get in and out to your house. Now, from this cutout that I've shown you, we will also have a double pole MCB. This is a double pole MCB, meaning it switches the live or the phase as well as the neutral. And then from there now, like I have demonstrated, we then have the energy meter. So this double pole will switch power to this energy meter. This energy meter is just for demonstration purposes. And then from the energy meter, we will also have a second double pole switch. This switch purposely switches electricity from now the energy all the way to the consumer unit. Okay. Now, how does a consumer unit look like? Someone came to my inbox and wanted to know. So if in your house you have ever seen something like this, then which is a consumer unit. This one specifically is a 12-way consumer unit. I love them as large as possible. This one has got some 2 years warranty here, and it has an MCB, a DP MCB, and I can have several MCBs here. Now, this consumer unit is a 12-way, meaning it can accommodate several MCBs or several miniature circuit breakers. How do circuit breakers look like? This is how a circuit breaker looks like. Now, several MCBs are usually connected depending on the circuit that they are supporting or the circuits that has been wired in that installation. Could be a house, it could be an investment of any kind. Now, a loose connection that happens on these double cutouts is basically due to connections of wires or and another wire here. Most of these cases you find that a wire that is coming in the cutout is normally a drop cable from the national grid. Once it gets here, there is this switch, and then a connection will come all the way to uh, this part, which is the negative. I mean the neutral will come through here, the neutral, and get to this part here. Very important part, as you can see, because here now you'll get a looping for the neutral that is outgoing and an earthing connection which will now be looped to the meter box, as well as the outgoing wire or cable which will now be fed to the consumer unit, and that wire is usually in green and yellow stripes or yellow with green stripes. Now from there, another wire will be connected here, again a green with yellow stripes, all the way to the ground. And on the ground, there is what we refer to as an earth rod. Very, very important, because it is an important part where now you will have the charges discharged to the ground. Very, very important, because it is an important part where so there will be an earth rod. That is how the fuse looks like. So this fuse is from a cutout, and this fuse, if you can see there, is being held at this part as well as this part, so that electricity will flow through these connections that are here. Right. So the rating of this fuse is also indicated, whereby we have 60/80 amperes. Don't know whether in this specific fuse it's indicated, but as you can see, it is 60/80 amperes. And this cutout looks like this. What I have here is a double cutout. This is a double cutout. So you have the face here, and then we have this bar. This bar carries the neutral. The neutral will get in here from the supply, and then it will get out here to go to other connections. We also have the earthing connection now, also tapped from this line here, so that the earth connection that will go to the consumer unit, as well as the one that is going to the earth road. So that is about the cutout. Then we have said that it is important to have these connections done with a screwdriver so that you have very tight connections. Most people make a mistake connecting or probably screwing with a tester. A tester will not make a good connection there because you will not be able to tighten that screw. So it means that that connection will be loose, right? So, and we don't want to have that in our electrical connection. We don't want to create loose parts, or probably we don't want to come up with connections that are loose. This will mean that it is trouble or creating a problem to the electrical path. So we want to simply maintain a connection that is very, very tight. Also, when connecting this part here, you make sure that it's tight, because that is also another recipe for disaster if at all these connections are not tight. Electrical connections must be very, very tight. So you need to have a very tight connection at that. And then when it comes to the double pole switch, the first one that is actually energizing this meter now from the cutout, again, at that point, like we have indicated earlier, it is important to have those wires, the ones coming in the double pole switch, the ones coming out the switch must be very, very tight. And why is that? Because again, this double pole switch is interrupting the path of electricity. And when it is interrupting, we need to make sure that that path is very easy for electricity to flow through. So whenever we create that interruption through this switch or whatever gadget or device, we must ensure that it is very, very tight and smooth, or probably safer and easier for electricity to flow. So when we get again to the energy meter, the energy meter has several connections. Most of the energy meters have four, where you have the incoming and going termination. Now, for the sake of this connection or of this energy meter here, what you can see is an incoming phase and an outgoing phase. These are connected here at these first terminations, and we also have an incoming neutral connection there and an outgoing neutral connection there that will be connected. Now, this energy meter is simply used, I'm using it for demonstration purposes, but most of the energy meters as we have right now are what we refer to as the token or the prepaid energy meters. We also have the postpaid. Now, those are simply devices or gadgets that are used for billing, just to bill, but it is not a protective gadget. It will not protect your circuit, and in the event that there is a problem in the incoming electricity, or probably there is a problem in your house wiring or the electrical installation in that case. Now, from the energy meter now, we also have a double cutout. The second double cutout or the second main switch in the meter box. This now will switch power to the consumer unit. And we have said that our consumer unit uh, is here. And before I show you, at the energy meter, the connections must be very tight. These connections must always be mechanically sound and electrically sound. What do I mean by that? A mechanically sound connection should be very tight, meaning once you are screwing those screws on whatever appliances or gadgets, you make sure that they are firmly done. And what do I mean by electrically sound? It means that, for instance, if you are stripping an insulation off of a wire, you make sure you do a good stripping so that you can expose the copper material. And when you connect it, you don't halfway, you don't strip halfway, but you strip the entire copper wire so that when you connect, there is that flow of electricity which will be perfect, meaning you have not screwed the insulation. So that makes a connection electrically sound. Now from there now, we'll get now to the consumer unit. That is also another area where we usually have a lot of problems, because also at the consumer unit, you want to make sure that whatever connections that are done here inside the consumer unit are also electrically sound and mechanically sound. Now here we will find that there is a miniature circuit breaker, a double pole one, and then we will also have several of them here. All of these are placed on the path of this electricity, and this electricity will not want to have all of these interruptions. It will want a path, or it will desire, I'm referring to it as if it's a human being or an animal, or it's something that has a feeling. If electrons had a feelings, it would make physics so hard. There's a physicist that once said that. But my point is, on this electricity path, electricity from the transformer all the way to the appliance, whatever appliance or a gadget or a bulb that we connect to it, would even be very much easier overroute if it did not have any interruptions. Could it be this device? Could it be this MCB, miniature circuit breaker? But we have to have them so that we protect ourselves as humans, and also probably our pets or our animals that we live with, so that we don't have any electrical hazards. So once we interrupt the circuit or the flow of electricity using these protective devices, what we need to do is to ensure that the connections that we do are perfect. So even at the consumer unit, if you go wrong with the connections, then there is a problem, because there will be a strain in the way that electricity flows through all of those protective devices. Now, most of the electricians make these mistakes by making loose connections, and these come from probably you're using the wrong tool while at it. For instance, when you're making a connection at the energy meter, there are several screws that are here. We have 8 in total, screwing the incoming phase, the outgoing phase, and the incoming neutral and the outgoing neutral. Now, it is important for you to note that, as I have indicated, electricity will flow back and forth all the way to the appliance and back to the origin, or back to the source, which in our case is the transformer. If you are using a battery, then the battery is the source, and electrons will tend to flow from the positive terminal or the positive connection back to the battery through the neutral, through the negative connection, and the neutral for the case of AC or alternating current, which is the transformer. Now, as electricity gets back, if you have a loose connection, especially at the neutral, then there will be something that we refer to as arcing. arcing is whereby there is some sparks that have been generated due to that loose connection. This will now definitely affect that loop or that path, which will now cause bulbs to flicker, which will cause electronics or electrical appliances to sometimes go on and off. This phenomenon can make an electrical appliance to receive voltage that are less than what it is required for it to operate perfectly. For instance, if you have a loose connection on this switch, it means that if you have connected a load of, let's say, a fridge, or probably you have a deep freezer, then there will be a problem because it will strain to get insufficient current. Now, in that process, your appliance might be damaged or it may go on and off as it is struggling to get electricity from this point here. So it is important to ensure that the connection is perfectly done. It is not advisable to use a tester. A tester should be used for only that purpose, to test the presence or the flow of, the presence of electricity. So once you place it there, that should be it. And also tightening very small connections or screws. But for making connections that are tight, that are sound mechanically, it is important to use this screwdriver. Let us engage in the charts. Let me know how this is coming along for you. I also have another important device that I will be showing you here. This is a switch. It is also referred to as a double pole switch or a DP switch. This switch is mainly used in heaters. It is also used in instant shower heads. As you can see, it has a heavy switching gear right there. So it is usually referred to as a double pole switch because it can switch the load to electricity through the live connection or the phase. As you can see, it is indicated there. This is the supply connection. You have the live and then you have neutral. So this is the supply, or basically the incoming from the consumer unit. And then you have the load there, or the outgoing connection, where you also have the load as well as the neutral. So this switch is switching this way vertically. So when you have this one, when you put it off, then you have switched vertically, you have switched the phase there, the incoming phase, the supply, and phase, which is the load. You have also switched the incoming neutral, which is the supply, and the outgoing neutral, which is the load or the appliance that you have connected. Now, if at all these connections that you do here are not tight, are not mechanically sound and electrically sound, then there will be a problem. There will be arcing here. There will be a lot of strain as electricity is being conducted through here. And that will mean that your appliances may not function as they are supposed to. So that is why we emphasize on the importance of having connections that have been tightly made. Now, up to there, it is also important to note that most of the appliances will get damaged in the event that this is happening. For instance, if a fridge is not receiving sufficient current or supply of electricity, then it will get damaged. Some of the parts in that fridge, especially the compressor, do not really appreciate when they receive an under voltage. For instance, here in Kenya, our voltage supply is 240. That is on the low voltage line. So that is the voltage that comes to our houses. And if at all that voltage can get to, let's say, around 150 or 110. Sometimes it can get to 180. Then that compressor in that particular fridge will strain to get its electricity, and that means that there will be a problem in its operation, meaning it will not be able to function as it's supposed to. So that may also result to its damage. So that is an important aspect, whereby if at all we have uh, and under voltage due to these loose connections, our appliances will then have problems operating. If you have a bulb that is flickering, you need to check on that. Most of the people who ask me about the loose connections, I refer to them to check on those connections in the meter box as well as in the consumer unit. And specifically, when you get to the consumer unit, there is something you can also check. And on the consumer unit, there is what we refer to as a neutral bar. We also have a bar for the earth connection. So this is my consumer unit. I love them big because they can accommodate several circuits. Because in a house, we have several circuits. And if at all someone has several instant shower heads, or probably has several water heaters or other circuits, then they will be able to connect a lot of gadgets here. So just to show you some of the main features of a consumer unit, um, we have them here. Have this bar which connects the MCBs, and this bar has 1 2 3 4 5 6 7 8 9 10 11 12 13. The extra one is to loop from this connection here, or probably what we refer to as the double pole switch. So there are some features that I would want to show you closely. So these important features are: we have the earth bar. This is the earth bar in the consumer unit. We also have another one. This is now the good thing about having a bigger consumer unit. These are 12-way. And we also have the neutral. This is the neutral bar, as well as another neutral bar there. In total, you can connect several wires here. Have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 minus 2 for connecting the main supply here, and also for looping the two, or probably having another main supply here. So once you have these connections here, if at all there is a problem again in the way that your bulbs are operating or your appliances are operating, it is important to also check on these connections here, where if there is a loose connection on these neutral bars, the two of them, or either whatever appliance has been connected here and it loose, then it means that it will not operate as it is supposed to. A loose connection on the earthing side may result to something. Let me know in the chat what you think. What do you think a loose connection on the earthing side can cause? Right? My good friend who is watching, if a loose connection occurs on the neutral, then an appliance will misbehave. Probably it will not receive sufficient electricity or current. But what happens when there is a loose connection on the earthing connection? Let me know from the chat. Now, this is a very important feature of this consumer unit, because this is what now interconnects the face and the MCBs, right? So once you have that, let me just have it. Once you have this double pole here connected there, you would want to loop this double pole with to the other MCBs, an MCB. So you would want to, first of all, you connect it like so, and then you would want to loop the two like so. We just have them there. So you'd want to loop them like so. So this is an important part whereby you must ensure that those connections there, as you screw those screws both on the double pole switch, the DP MCB, as well as the MCB there, we have the 32 MCB. You must ensure that that connection is very tight, because again, if at all it is loose, it is a recipe for disaster. So we want to ensure that all our connections, all the way from the meter box, any part, any device, any feature in the meter box must be well connected. And so when we also get to that consumer unit, we also want to have very tightly done connections. So once you have this consumer unit, like I was saying, forgive me, for today we are practical board. As you already know, we have our practical board where I will be wiring this consumer unit, as well as uh, indicating why I use the gadgets that we'll be using, some of the wires that we'll be using for different circuits, the size that we'll be using there, and why will we be using that size, the specific size. I will also be talking about that, and I believe that it will be an interesting topic that you will not want to miss, of course. So once we have that bar tightened there, we can connect all our MCBs there and have our consumer unit as safe as it should be. This is an important safety measure, because most of the time you'll find that also when these appliances have not been well terminated, have not been well connected, they will tend to give or to have charges on their metallic surfaces. Let's say you're using a refrigerator or probably an electric cooker. You find that if at all the connections have not been well done, you will have cases of electric shock, receiving an electric shock once you touch or you come in contact with the metallic surfaces. This will lead to a hazardous event whereby someone can easily be injured through that scenario, because again, electricity will be trying to flow back to the source through you as you receive that electric shock. And the source, as we have indicated, is the transformer. So once you come in contact with an appliance that has all these charges, then it simply means that electricity will be trying to get an easier and faster route or route to get back to the source, which is the transformer. And this route will definitely be your body. And that causes pain to the person receiving this electric shock, and it is an awful or a bad experience. Sometimes can also lead to death. So we don't want to get into that. We can avoid that by ensuring that electrical connections are safe and they are very tightly done, and they'll be able to protect the users as well as the appliances. An electric an electrical leakage or a charge leakage on electrical appliances can also damage those appliances. So that is why it is important for you to ensure that your earthing connection represented by this wire. This wire is normally yellow with green stripes or green with yellow stripes. And for every circuit, it is important to have it. Someone was asking me whether there should be an earthing connection on the lighting system, and I say yes. It is very important to have an earthing connection on each and every circuit. So this is very important. This protects your appliances as well as protects anyone that uses appliances or uses the electrical installation in that house or in that establishment. So that is it for today. My name is John, and this is Top Lights Electricals and Electricians. Until next time, thank you so much for tuning in for this live. If you are watching it on replay, kindly smash that like button if there's some value that you have received in this video. For more coming videos, I'll be talking about other safety precautions that we need to have, as well as connecting all of these gadgets that are meant to safeguard our appliances, as well as all of us as users of this electricity, and help us be safe while using this electricity. In the meantime, subscribe to my channel so that you don't miss any episode. Thank you so much. If you are already a subscriber, see you in the next one. Bye bye.